The shape is always square, right? I mean, it's always contact. So PRMS only for AC. Sorry.
Example, that EG for 100 volts, you decide for 0.6, then VDC for VVD 0.6 times 100 equals 60 volts. Here VDC less than VD, means this is step down, converter. This is step down converter. VD, the input, 100 volt, VDC, DVD, V given, so VDC for VD, the output voltage 60, so this is input. This input. And this is out.
But the formula is the same with VRMS, right? The integral
No,
formula.
for RMS, I would like.
Yes.
So VDS then VD guiding about step up. Now, V output mean square. V output mean square. Root mean 1 over Ts. Integral from 0 to T on square. So V D VD square. And because
Will be the same.
maybe square or rectangular waveform, so we can direct the amplitude square by the width. Direct. VDC, VD, sorry, VD square divided by Ts, T on. Now T on to Ts duty cycle. So we are RMS for VD. Square duty cycle. Okay, this is input. Input here. Yes, and this is output. Walking, but not this. And this is duty cycle. Oh. on just VD, V out, okay? It's not voltage level. This is just the VDC, the DC voltage level, but this is AC. No, yes. And again, now we have V out DC. This is V out DC equal duty cycle VD, and V out RMS as AC equal square root D VD, and I out DC equal V out DC over R, or equal dVD over R, and I out RMS equal V out RMS over R, or equal square root dVD over R. Now, this equation require for
And the graph, it will be the same, right? It will be the same square, right? For VORMS. It, like the picture, it will be similar, right?
I answer no this equation. No way for RMS.
Yeah.
DC, this DC. RMS is, this is just
Same thing.
term and AC. This is term and AC. That's no need to write. Also the DC just indicate the RMS, but the DC, but the RMS is no area. It's not area. Why? Because VD square, this is not area. But VD by time is area in the curve. But VD square times T on, no, this is not area. Okay. AC. But now, I have another formula. This one. Okay, say V out DC for dVD. I have another formula for the output. Okay, according to Ohm's law, I equal V divided by R. Okay, but in terms of a duty cycle, dVD over R. Okay, but I want I out DC in terms of ID. See, again, let me draw the circuit, this phase, this input voltage VD, and this is R. VDC, this is IDC, and this is ID. Okay? This collector, emitter, base. We say V out DC equal dVD, right? Now I out DC equal 1 over dID. 1 over. Okay? V out DC equal dVD, while I out DC equal 1 over dID. Okay? This equation is very important. Why we need ID? We need ID. Why we need ID? Because ID is the output of the solar cell. DC converter with the solar panel. Okay? With the solar panel. This is number 4, right? You have 5 and 5, 6. We have 2 weeks more. Week number 7, exam 1, and week number 8, mid-term exam. Okay? Almost. Almost done now. Or so, maybe next semester, I will suggest 4 classes to the department for graduate students. High voltage DC, machine, fundamental drive, machine, advanced drive machine, and power system stability. So I want to know if you okay, which class you
High DC voltage.
High DC voltage, yeah.
Yeah.
okay. So 2 classes. Yes, I will teach 2 of them, 2 classes.
Yeah.
And if you're copy, another.
I think I've made
So,
this right. Geoprotected fundamental.
Dr. Hobi, Dr. Hobi.
So it depends, I will suggest to the department and I will discuss I discuss with the and I will discuss with Dr. Komar about that. So, because these classes not offered last year and this year, so we will offer next semester, next year. Okay. So maybe most students need advanced and fundamental of electrical machine drive.
Fundamental.
Fundamental and advanced, yeah, 2 classes.
Yes.
No, it's just like, I don't know, the advanced, I suggested with Dr. Ali, but I don't know. No, I suggested to Dr. Ali to suggest this in class, okay? But the syllabus is different. The syllabus should be include generalized machine theory, matrix, information of the machine, not the same, but the last year, no, they put it the advanced and fundamental same the syllabus.
Have to change that.
Fundamental, yeah, sure, I will change it. Or if Dr. Kofi teach it, he will change it. The syllabus, sure. Okay? So this is for spring. For summer, maybe I will offer renewable energy. No, renewable energy, sorry. Wind and solar cell
This is a.
generate.
We didn't take this one.
No, this is new.
Sounds to me this
It's a special topic and solar cell and wind turbine sources, not renewable. It's different.
So we cannot do it in the spring?
I think advanced.
No.
Yeah,
High
no,
DC and fundamental.
Yeah, because
Sorry.
summer,
Yeah.
summer, I need summer, why? Because we need more students. And this is new class.
Those 2 classes good, Dr. Abu.
HVDC and the
Yeah.
fundamental machine,
Yeah, those 2 classes really good.
yeah, for the fall.
Next semester, no, spring.
Spring, yeah.
High
Next
voltage and?
And the fundamental
Of machine.
machine.
Oh.
HVDC and fundamental,
Oh.
yeah.
High voltage and fundamental, okay. And,
Where's fundamental?
advanced and, stability, maybe your,
Coffee, yeah.
Or,
Total data of
yes, maybe the talk of just advanced.
Teacher.
I will, call them to. Okay, now, this, formula is very important, why? Example. Example. Design a solar cell system with the following. Then, see, R load equal 100 ohm. V load or V out DC equal, see, I changed the letter, V out, VL, VDC, capital letter or small letter, uppercase, lowercase, same should be known the concept. This is V load DC, okay? V load DC equal 200 volts DC load duty cycle equal 0.6 that's it. This is design, right? Design should be first step, draw the circuit diagram. Okay? Should draw the circuit diagram. Circuit diagram? Okay. Design a solar cell system with the following data, RL, load using a duty cycle. Duty cycle, where is the duty cycle? Where you talk duty cycle and DC to DC? I don't know, is the, now as the, just step down, so we will use step down, okay, and we have the 200 volt output, I can, put here step down converter, okay, but the exam, no, I will decide step down, step up, or I will give you some numbers and you should know this is step down or step up. You will use step down or step up, okay? But now it's because we took just the step down converter, this one. So now draw the circuit diagram, this one, RL equal 100 ohm, this is V load, transistor, you can use any switch device or transistor. This emitter, this collector, this base. See here, this is IL DC, and this is ID. When this is not open circuit, this is connected to the control circuit, but is sometimes plugged in, but it's connected to the circuit. This positive, negative, VD, and here first step, we draw the circuit diagram, okay? And then we will design this one. You are designer now. First step, we draw the circuit, then should be calculate VD and ID. Okay, VD and ID. VD and ID. Then after that, we will design the solar cell panel or panels. This example, there are two circuits per circuit. This is general circuit. Okay, one panel equivalent, but then we will calculate the multiple panels connected series or parallel or limit. VD and I, depend on VD and I. So now, first step. The calculations is VDC, V load DC equal duty cycle V. V load DC 200. Duty cycle 0.6 V. So VD equal equal 3.33 volt. So we need a solar cell generate 3.33 volts. Possible large voltage, so it should be cascade more panels, 3 or 4 or 5, depending on the available the market. Okay. Now, ID. Let me check ID also. I load DC equal V load DC divided by R. We have V load DC. We have V load DC. V load DC 200. Divide R 2 ampere. So 200 divided by 100, so equal 2 ampere. Okay. And now 2 ampere. I load DC equal 1 over D ID. We have I load DC 2 ampere. 1 over 0.6 ID. So ID equal 1.2 ampere. So now we need a solar cell generate just 1.2 ampere. 1.2 ampere, but the voltage is 333.333. 333 is difficult to get this voltage exactly same value. So you can make this one 360. 360 or 340, more than the calculated value. So now choose 340 or 350. Choose DD 350 volt, ID 1.2 2 ampere. 2 ampere. You are a designer. You can't, but please select VD and ID more than calculated value, not less than. Why? Because if you select ID less than 1.2 or VD less than 333.33, maybe the load need more power. Okay, so use VD and ID more than calculated value because you are designer. Now 350, we selected 350, we can use, you can select 340 or 360, okay, but not 400, no, it's close to the value,
Okay.
calculated value. Now, 350, 2 ampere, okay, 350, 2 ampere, 350, if we have, panel generate, we have solar cell panel generate 20 or 10 volt output at 2 ampere. So select solar cell panel of 10 volt 2 ampere DC rating. So we have 2 ampere is 2 ampere, okay. 350 and each one 10, we can divide 350 divide by 10 equal 35. So here solar panel 1, 2, 35 generate 2 ampere, each of 2 ampere series, okay. This volt is 10 volt, 10 volt to 10 volt. Total voltage generated at the terminal of this grid is 350 volt, connected to the DC to DC converter, connected to this one and this positive, negative, and this are load under it on. Okay, this collector, emitter, base. Okay, so we need 35. We need 35 solar cell panels to generate 350 volt, 2 ampere are connected in series. Yes, sir.
Why is it 10 volt per solar panel?
You are designer.
Yeah.
Okay, we select 10. Maybe another student select 20.
Oh, okay.
And I will select 15.
Cool.
Depend.
So
Okay,
does
you
it
can.
matter for that one or?
Yeah. This is, see, this is design. Design, you can select any value standard from the market.
Okay.
10 or 15, 20, 120. If you select 120, you need just 3 panels. 1, 2, 3. Okay?
Yeah.
3, 120, 120, 120 equal 360. In the exam, I will give you the data for different different numbers available in the market. So you can design according to the table given.
Okay.
Okay? Available value. Same, I will put protection, power system protection. Or no.
No.
Select the
The
CT
Oh,
ratio and okay.
Yeah.
Same selection of
Okay.
the circuit breaker size or available 10 2 ampere.
Okay.
Okay.
Yeah.
But 120 volts and generate 2 ampere, this is not standard. But 10 volts and generate 2 ampere available.
Okay.
Okay? But I will give you table of different sizes available. Okay?
Okay.
Don't worry about that. Any question? Any question? I think the break 10 minutes. After the break, continue. Step up. Exam tomorrow, right?
Yeah.
Yeah, if you want to leave, it's fine.
Okay.
Or, okay. Yeah, other material. If you want, I will explain it like anytime. Next week before the class. I will explain if you want.
Okay.
Anh ấn các em theo anh cũng làm theo. Thì từng giờ anh em theo cái drive.
And if you have
Cái này anh
question about
Cái này cũng phải có cái cable với chiếu có được đang thâu.